Yo, what's up? Matt Foreman here, continuing our engineering stream where we left off. We are building a phone stand, a phone charging stand. So just a little recap if you didn't catch the last stream. I want to build a 3D printed phone charging stand that uses this wireless charging pad to charge your phone. You'll be able to just set your phone down on it and let it charge. It's similar to this one. This is just a regular phone charging stand. It can hold your phone this way or this way. And I wanted to make something like that that would also charge your phone and could pivot at whatever angle you wanted. So last stream, I will show you how far we got. We got to this point. So we got our little charging stand here, which ended up looking like a little dude holding your phone, and someone decided that we should put a happy face on there, so that was a very nice touch. And this holds your phone either sideways this way or vertically that way, and either way it holds your phone. It makes sure that it's centered so that it charges your phone either way. Now what we attempted to do on the last stream was make a hinge on the back. This is as far as we got. And I was going to do a 3D printed hinge, but that did not go well. I started the 3D print and the print failed. And also I realized the way that I had the support material arranged was not the right way to do things. I'll show you the aftermath of the 3D printed part. Let me go grab it really quick. I'll be right back. So this is how the attempted 3D print turned out. All we got was this. This is it. Because it had to build up support material and it was printing in an orientation where it was working on this piece of the part. And also, when I removed the support material, this cracked. So this hinge design is not going to work at all. And I'll show you why. I'll open the 3D printing slicer and actually go into some detail on why this wouldn't work. So give me 1 second to open that up. Let's see. Phone charging stand. Open our project here. So it's slicing the layers for the 3D printer. So just to recap, when you're 3D printing something, it builds it up layer by layer, meaning that there's just a little nozzle that extrudes a plastic line, and it just builds the model up like that. And all of this material that you see right here, all of this like grid, like right in here, is support material because it's laying on its back and it has to have support once it gets up to the back so that it can actually 3D print the rest of the model. So the print got right about up to here. Like right about up to here when it failed. And then I tried removing the support and it cracked because what I overlooked is that the support material, it goes through here as one piece. And that's not good. We don't want it to go through there as one piece. Because when you try and take it off the supports, it breaks. So we are going to honestly just completely get rid of this hinge and go with something else. I was hoping that we could use a fully just 3D printed plastic part, but we're going to have to use metal hardware. And that's going to be for two reasons. The first reason is obviously that this is, difficult to 3D print in this orientation. But what I also realized is that it's not going to be good to have this actually attached to the back of here as one piece, because when you 3D print, all this support material needs to be built up. And I would rather just print it flat on its back, starting from like, if I move this down, I would rather it start like right here, so that when it starts 3D printing, one second, it's slicing. So that when it starts 3D printing, it just starts working on that right away, and it doesn't have to build up a ton of material underneath. And it cuts down on the print time majorly. This was going to be a 15-hour print, and right now, just me moving it down that much made this into a 6-hour print. Obviously, there's going to be more pieces than that, but at the same time, it's going to make this whole thing easier to 3D print for anyone who wants to make one. And we are going to use hardware from McMaster, which is kind of like a hardware store, but it's online. And I like it because the parts usually get here the next day. And they also provide 3D CAD models that I can just pop right into my design. So I really like that as well. And we are going to search around on McMaster for a bolt to use in this hinge instead of this big old plastic piece right here. We're actually going to use metal hardware to create a hinge, and I'm just going to kind of whip up a design for that, I guess. We're going to first look for a bolt, and one that I found was a carriage bolt. And why we're using a carriage bolt is because it has it's square right here so that it can go in and it won't rotate around. And then we're going to screw a kind of like a thumb nut on the other side so that you can just tighten it by hand. And I think this will work really well, and we don't have to deal with 3D printing plastic threads, which is kind of crappy sometimes. And the threads have to be huge for them to actually work and not break. And I would just rather use metal hardware, honestly. It's going to work better. So that's what we're going to do. And so I just need to figure out what length I want. We're going to use metric bolts because the metric system is better. Imperial system needs to go away in the United States, but it won't. So I think we're going to use an M6, which means it has a 6-inch diameter. And we just need to pick the right length. And I usually, when I'm picking lengths of stuff, I just kind of like, I use this caliper to get like a real world view of what it's going to be. And so we'll probably want this to be like 25 would be a good, well, doesn't hurt to go a little longer. We'll go with the 30. And that's partially threaded. I just got to make sure that the threads will go all the way through. 18mm thread length, meaning that we get 8mm of unthreaded. Yeah, I think that should work okay. So let's grab this bolt. We're going to save the 3D step file that we can import into Fusion 360. Let's do that. And they didn't name it in a way that's very good, so I'm going to rename it just to, well, I'll leave the part number in there, but this is an M6 by 1mm by 30mm long. So that'll at least just give me an I'll get rid of the spaces. We don't really need those. So that'll give me an idea of what it is by the file name. And then we're gonna pick a thumb nut to match that. Now I was gonna just use a plastic thumb nut at first, but I don't think they have a CAD file for the M6. No, they don't. So I mean, that's not a good reason not to pick apart, because you could just buy the part and then see if it fits up, or make a 3D CAD file yourself. But instead of doing that, I'm just going to take the easy route. And I kind of just like how this one looks, the brass flanged, knurled head thumb nut. But we're going to go with the metric version. And I have that pulled up here. M6, 1mm thread, which is what this is. So that should work well with this. So I'll save that file as well. So M6 by 1mm. Cool. So we got our CAD files, and let's bring them in. Upload. We are almost there. All right. So I'm just going to bring it into the assembly just so we have a sense of scale here. First I'll do the bolt. Yeah, that's gonna be about the right size we need. So that's gonna go here. I'll just leave that right there for now. And then let's bring in that thumb nut. Okay. And then that is come on. That's lagging a little bit. And that's just gonna fit on like that. So I'm just gonna leave that right there. And we'll get into this design, but if we need to get a longer bolt, that'll be fine. And I'm also gonna look, reviewing this, I'm also gonna look at the center of mass. And you ideally want the center of mass to be right above the pivot, because if we're using a base that comes straight down, then it's not going to want to tilt forward or backward. And I think having it lower is actually good, because your chances are you're going to have it tilted up just a little bit at least. So then the center of mass, just by eyeballing it, it's going to be, first of all, your phone center of mass is here. The center of mass of this thing is probably right here. So then that's the lower the better then. Now if you tilt it horizontal, obviously your center of mass is going to be tilted more that way, but it doesn't matter if you go up or down, it's still going to be that way. So yeah, I think that's going to work okay. I'll save this. And then we need to work on this guy, start redesigning him. So we're going to have to get rid of this. And let's see. Where did we leave off? Where did we start on that? Okay, that feature through there. So I'm going to suppress all these features just to make sure. Okay. So it looks like a couple of these other features got suppressed along with that. I just want to make sure what those are. So it's that fillet. Oh, that makes sense because we have that intersection there. And it is that, which also should have been suppressed. So I'll just make a note of what this is. 1.5 millimeter fillet. And, you know, I think I'm actually just going to delete all this because I know I'm getting rid of it. We're not going to use it. So let's delete those features. We'll roll back to here and add that fillet back. And okay, we are hingeless. So now we're gonna start anew on there and see what we can do. So don't worry, we still got the happy face too. So one hinge design I kind of like is the ones that are used for GoPro mounts. So let me just see if I can find that and show you what I mean. GoPro Mount hinge. So the way these work is, here's a good one. Looks like this is 3D printed as well. So essentially, your bolt goes through, and it doesn't matter what kind of bolt we use because it's going to be the same either way. But I think we're going to use this type of hinge, and I'll probably make this part of the hinge attached to the phone stand and then this to the base, kind of like how they did it here. Because on the outer part, the carriage bolt's going to go in through here, and then the thumb nut that I just picked out and showed you is going to go through there. So I think we'll make that. So yeah, so that GoPro hinge design is going to go right here. So let's start working on that, huh? And oh, another thing I need to mention is we're going to make this a completely separate piece from here. This is not going to be one piece because it sucks to 3D print it out that way. Instead, we're going to make this screw into this piece. We'll just use some plastite screws, and then that should be just fine. I figured, you know, at first I wanted to make this completely so you could 3D print the entire design and not buy any metal hardware. Just use your 3D printer, but since we're moving to metal hardware for this anyway, I figure what's the big deal? I mean, you can get everything on McMaster. And when this design is done, I'm actually going to open source it, release all the drawings, all the files, everything, all the specs and blueprints, and links to the metal hardware as well, so you can get everything ahead of time. And honestly, by the time you're done 3D printing this, the screws will probably arrive anyway, because they only take a day to get to you. So with that in mind, let's start working on our hinge. And the thing to remember when designing our hinge is that this is a 6mm diameter. So we just have to have enough room to where it can support that, and with a little bit of play. So I am actually going to make a new sketch. And we're going to pick this middle plane here. And we're going to want this back face. And I'm actually going to... Oh, hang on. I need to start a new part, obviously, if we're making a new part. So we're going to undo that. So let's just start with a completely new part, huh? And first we'll just make a base for this hinge to fit onto. And we'll do that by just picking a rectangle here with a center rectangle. We'll make it a little higher than it is wide. And I think we'll adjust these dimensions later. But for now, I'll just make it 20 by 40. And maybe 20 by 30. And we'll extrude that up. Yeah, if the screws are going to screw into this, we're going to want a little bit of plastic for those threads to go into. $5mm should be good. And then we'll add on to this. I'm not going to actually use that plane. We'll start a new sketch. Go sideways. I need to grab this line so we can dimension off of it. So we'll project off of there. And now we pick where our bolt is going to go through. So our bolt is a 6mm in diameter, but we got to make the clearance hole. We got to give it a little bit of clearance. So let's go 6.6, give it 0.6mm of clearance. We'll see how that works in the first 3D test print. If it's not enough, we can always change it later. I'll just go to that midpoint and make that vertical. And I'm going to adjust this height a little later. So then we want to decide how much thickness we want. I think 4mm ought to be good. And like when I'm doing this quickly, how I check if I think it's going to be good is I just kind of eyeball it with my caliper. So 4mm, that's actually not going to be good enough. I would be comfortable with maybe 6 or 7mm of material. Actually, probably more. We're gonna go 8, which means I'll probably have to make this bigger. Well, looking at that again, I think we can probably go 6. Yeah, that should be good. And I'll just make this meet right there. Tangent. And then I'm going to make some lines here so that we'll go tangent to this. And another one. Tangent to there. And we'll make these equal. And then we got to specify an angle. And maybe 15 degrees. Yeah, that looks good. And now we'll extrude this. And we'll go symmetric. And I gotta see what we want to do as far as thickness goes. I'm gonna say 3mm. 3.5mm. I would go less, but because it's 3D printed, I want to give it a little more strength. And we're gonna need 2 of these, so I actually need to redefine the plane that this is going to be on and decide how much space we want. So I'm actually going to roll this back and define a new offset plane. So this is offset from the middle. And let's see, if we're going with a 3.5mm thickness, then we want the gap for one to fit into to be 3.5 plus 0.6mm. So that's going to be 4.1. That's what we want the gap to be, but I need to divide that by 2. The nice thing about Fusion 360 is that when you are dimensioning, you can do like little equations while you're in there, multiplications, whatever. You can even actually insert existing dimensions in there and it'll work properly. So yeah, so if we want the gap to be 3.5 plus our clearance of 0.6, and then divide that by 2 because we're going to mirror it over. So there's our offset plane. And we are going to redefine the sketch plane to our new offset plane here. And then I had it extruded in the middle, but instead of that, we want to only do it on one side and go that way. And then now we can mirror this over by mirroring the feature and selecting the middle plane. And look at that, we got a distance of 4.1 millimeters, which is exactly what we needed. And now I can tell I need to make some adjustments to this. The first thing I notice is that when you're tightening your bolts together, these are going to be squeezed together. And because of that, I might want to make this distance a little further away. Whoops, not that one. Instead of just making that tangent, I think I should make it a little further away because that way there's more plastic for it to flex. So let's just dimension that out to be, say, 12 looks good. So we'll go with 12. Finish that up. And that looks a little better. That's a little closer to the GoPro mount we're looking at. Actually, they didn't use quite as much as I did. They actually had it pretty much how I had it earlier. But I want to give it a little more flex just because it's 3D printed. I think that'll help. But you know what? They 3D printed that and it's fine. Maybe just a tiny bit. We'll meet in the middle. Go 11. Boom. Done. And obviously now we need to make our base bigger because we need to make 4 screw holes for this to... This is going to fit onto the back of this right here. So I'm going to save this right away. So what should I call this? Hinge. Hinge rear. Okay. And then let's just bring this into here so we can see what we're doing. I'll have to save this to get rid of that. And then I'll have to update the model, and then this will disappear. There we go. And now I'll bring in our hinge. And it might be too early for me to assemble this, but I'm just going to do it anyway. We can always fix it later. So there we go. That's going to fit like that. And I'll align all this later. But now we got to make this big enough and put some screw holes in there so that this can actually attach to this. So what I am going to do is go back to this sketch and make the base bigger. So I'm just going to oversize it so that we'll adjust it later. So we'll make that 40 by 60. And then that should give us enough room to put screw holes. That'll give us more than enough room. And I am using plastite screws. And I can't remember exactly what size they are, but I have a different design that uses these screws. So I'm just going to go measure off of that. It's actually for the Halloween costume I built. I'll show you that as long as I'm in here too. Pretty cool. So this was a Halloween costume I built, and I'm just gonna grab the dimension I know that I need. As long as I'm in here, I'll explain to you what this is. This is a cybernetic implant looking thing. For Halloween, I was an android, so I wanted to build like a cybernetic implant looking thing. So all these things are LEDs, and this was actually so fun to make. Honestly, there's a little LCD screen here. Actually, it's an OLED screen, and all these LEDs pulse in really interesting patterns and stuff. But the only reason I have this open for this thing is to grab this radius, which is 1.397 millimeters. You probably can't see it because it tells me that info in the lower right corner, but you can just trust me on that one. So with a radius of 1.397 millimeters, we'll go to this hinge and make a hole. So because it's a radius, 1.397, and we have to multiply that by 2. So yeah, we definitely oversized that, didn't we? 1.397. Okay. Cool. So now we just need to kind of roughly place that where we think it'll work well. So let's dimension that from the center. Probably we're gonna go 15 millimeters. And then from this side we'll go 9. And I think that'll work well. Yeah, so let's extrude that through. We'll go through all. And there's our screw hole that we're going to pattern now. We'll use a rectangular pattern and we'll go that direction. And then for our second direction, quantity, distance, direction type, one direction. I gotta remember how to do this. There's a way to make like a grid, and I'm trying to remember how to do that. Usually when I do a rectangular pattern, it's most of the time just in one direction. But we're doing a whole pattern here. Oh, I think it's because I just have to do this. Then it'll go the other way. Yeah. So negative. It's actually easier to do this in the sketch. Like, I could do it that way. There's always multiple things you can... multiple ways to do the same thing. Same thing with coding. They're like... when you're coding, there's like 4 different ways to do the same thing that you're trying to do. And you usually try and pick what you think is the most efficient one and then realize it's not and then start over. So we can just do that. And we'll make that dimension equal to that one. And we'll make this dimension equal to that one. So what I'm doing here is this dimension is actually driving that one. So I could change this location. If I change that to say 20, then they would move an equal amount. And the last thing I need to do is just make these equal. And then instead of using a rectangular pattern, I can just mirror this whole pattern over and it'll work fine that way. So we'll do a mirror. Then we'll select. I can't select it because it's inside my part. Do it the manual way. And there we go. We got our whole pattern. So now that we have our whole pattern, let's see how far away these are. Well, they're 30 millimeters apart, the center of them. And okay, so I think I know how big I need to make this. So 32, or let's try 35 for that. And I forgot how far I placed it out. I think it was 9, so 18. 25. That looks pretty good, but I want a little more on the vertical. Oops, not 4. 40. All about finding that sweet spot. 38. And then I want this to be a little more. Almost there. All right, I'm happy with that. So now that that is designed, what we need to do now is add some fillets. So first we'll do these. That looks good. And we want to hit these corners as well. Now, while I'm designing this, I also am thinking about the orientation for 3D printing. The 3.5 looks good for that. And I think the best, yeah, it's obvious. It's going to be 3D printed like this. So that's going to take no time at all. It's not going to use any support material. And it should be pretty strong. If I wanted it slightly stronger, I could maybe print it that way, but that's just not worth it. And it would require support material. So because I'm printing it this way, I should be able to add a fillet all the way around here and get it looking a little smooth. So we'll just do a 1mm fillet there. And I think this part should be done then. So let's see how close I got to the GoPro mount, huh? So we got this like that, and then our GoPro mount is that. That's pretty good, I'd say. Yeah, I like how that turned out. I'll save that. And then we'll go back to, we don't need this anymore. Go back to this. Boom. Hell yeah. So now I need to add a whole pattern onto this for the screws to go through. Oh, I shouldn't have closed that because I actually need another dimension off of that. Okay. Well, that's okay. We can reopen it. So the whole dimension I specifically need is on this piece. So I'm just going to open that one. close that one. All right, so this is this piece the screw fits into, and this is a clearance hole. So that radius, again, you can't see it because it's in the lower right corner. It's 1.905 millimeters. So we are going to use that. And I'm just going to have this whole pattern open for reference. Because we're going to be modifying this guy. I'm just going to roughly do that. And the spacing is 30 millimeters. So I'm just going to make a construction line between these. Got to make sure that's vertical. Well, it looks like that didn't get attached to there, so we'll do that. So that's 30. You know what a better way to do this is? We're just going to use a center rectangle. That is 30 by, I think our whole pattern was 18. Yep, 30 by 18. Cool, so we're done with this. And then we'll position it vertically from the center. So I don't need that dimension anymore. And this whole rectangle is construction, so I'll make that construction. And then we just need to place our circles on each corner. I'll just make some more. And the diameter was 1.905, so we'll do 1.905, or the radius was 1.905. So to make it a diameter, we just multiply it by 2. And I'll make all of these equal. And then we just need to decide how far down we want the center of the whole pattern to be. So I'm just going to eyeball it here, and then we'll, oops. Now we want a little room to be able to screw those in. That looks pretty good though. $29.5. That's what we're going to go with. Now let's cut some holes. And we'll just go through all. I was hoping these holes wouldn't cover up the smiley face, and I don't think they will. But I am going to have to make clearance for the bolt heads, so we're going to have to get a little creative with that. Dude, yeah, I am in space. You like that? I got this like space video loop. Cool, so I'm gonna save that. And now we can actually attach this for good back here. So I got to get the latest part. And now our holes appear. All right, we're going to assemble. Assemble. We'll do a cylindrical joint. And then I think I need to fasten one more joint, and then we should be good. Yeah, we'll get that lower right corner. And then all that should line up properly. Boom. And we got a hinge. I'm going to turn off a few of these things just so we can see what we're looking at here. All right, so now our bolts are going to go through here. Our screws are going to go through here. Sorry, they're screws, not bolts. And I'm going to take a measurement off of this part. So let's see, how thick did I make that? 1.75 millimeters. And we want to get it a little thinner, I think, because we don't have much room to work with there because we got to fit our charging stand in there. Right now it is 3 millimeters thick, and the bolt head is... I gotta find out that. Oh, it's so... To get this program, did you try and do the startup license? For if you're like a business making under 100K, you should be able to get this for free. That's what I did, and it was like pretty instant, so I don't know why it's taken so long for you. Hopefully it doesn't take too long, man. That's annoying. As far as that depth goes, it does look like we need 1.75 millimeters there. Or else I think it's going to be too flimsy. So let's do that, and then I got to figure out how to make it so that the bolt heads aren't hitting against this charging pad when you actually set the charging pad in there. I'll show you what I mean in a second. I just got to figure this out first. All right, so I am going to roll back. I got to turn off the smiley face for now, unfortunately. We'll put it back later, I promise, in some way, shape, or form, because this is a little dude that holds your phone at this point. All right, so this radius is 3.175. Okay. Let's do a new sketch. .175 times 2. And there's our clearance. And we'll make all those equal. We don't have to dimension these because they have a place to go. They are referenced to our holes. So if we change our hole pattern, everything will just move together. Now that we got that, we'll extrude these that way. And I think I can go to object with an offset so that once I change this thickness, it'll still be correct. So we're going to go to object, and the offset is -1.75. And then our operation is cut. Boom, look at that. So I need to get a model of these screws in order to get this thing to fit together properly now. So I'm actually going to go dig up those screws and find out what they are. I have them laying over there, I think. So I'm just going to go grab the box really quick. And I'm also going to take a bathroom break really quick, so I will be right back, you guys. And we'll pick up right where we left off. Alright, we are back. And I figured out what screws we got. We need to find some 4mm plastite screws from McMaster. So I think I can just search up the part number. Sorry, this is probably a little boring. Plastite screws. For 20 half-inch All right, I think I'm just gonna log in and find my order here. So I gotta do that on my second screen. Hmm. Almost got it. Sorry, guys. Here we go. This is what we need. Number 4, 1/2 inch long, 20. Cool, and they have a CAD download, so we're gonna download that. That's gonna be 4-20 by 1/2 inch. And normally I'd pick a metric screw, but we already have a reference for a good plastic Imperial System screw, so we're just gonna keep it that way. Oops. So we're gonna go back to our project here. Okay. So we got our screw here. Oh, whoops. The wrong place to put it. Save that. Grab the latest. And let's bring in that screw. We'll worry about that later. It actually isn't a big deal. Even though it's a big error, I know what it is. I say moments before it crashes and I lose all my work. Alright, so let's put the screw where it needs to go. Cylindrical. And then a planer. Cool. Now the issue we're going to have is that the head of the screw is sticking up from that plastic. There are a couple different ways we could approach this problem. But ultimately, I think the best way is probably So we probably want to just build up a little more material in here for the charging pad to rest against. And then that can also serve as the points that you put the glue on to glue in the charging pad. Okay. So we want to get a distance from there to there. And it's just 1 millimeter, so I'm almost thinking we could just say screw it and make this, the back of this, thicker. Which I don't like doing, but I don't like doing that because I'm used to making plastic injection molded parts, and when you're doing that, the wall thickness actually has to be pretty thin. But here I don't think it's going to matter because we're 3D printing it, and obviously this part isn't injection moldable the way I have it. So because we're just 0.373 millimeters, we just need that much space. We'll just thicken this up a little bit and call it good. And that way I think we'll be able to keep our happy face well. So -10. Oh, actually, that is what I should have changed, not this. And I think that should take care of it. Cool, now that is sitting just below that surface. I think we should be good. And I wonder if we can bring our happy face back, huh? I think we will be able to. Yeah, we should be able to. I might bring his smile down just a little bit so that it's between there. That's probably good. Cool. So now the thickness of this is 4 millimeters, which is honestly a lot more than what we need. But because of that, we can make the smiley face more prominent. We'll make that -2. That way we got a big old smiley there. Cool. I think I'm just gonna add some fillets to this. All right, that looks good. I think we are set to go as far as that goes. And here's where we're at with our charging stand now. And that screw's too long, so we'll use a different one when we assemble it. But for the purpose of putting this together, that should work just fine. And we only need one screw there just to visualize what we're doing. And at this point, well, we can line up the bolt. Let's do that. We'll line up the bolt right there. And then we'll line up this as well. To the bolt. Cool. And I'm just gonna leave these farther away for now, because now we get to work on the stand. And I don't think that's going to be nearly as complex as what we've been doing for everything else. Because this guy took us a long time to make on the last stream. And even the modifications now took a while. Let's get a start on that stand. We'll start a new part and make something that fits into here. Okay. I don't think we need that anymore. We got what we needed off of that. Don't need that right now. Save our progress there. And this part is pretty much done, I would say. This looks good, and this is not going to take nearly as long to 3D print as the last one. Cool. Alright, so now we're going to make a new part, and we're actually going to keep this open because we're going to use the same profile, except it'll just be a vertical stand. Alright. I'm trying to think of the best way to start off this part. Do we start with the top, or do we start with the bottom and build our way up? I kind of think it's smarter to start at the bottom. So let's do that. We'll start at the bottom. We'll make a nice wide base. We'll make that pretty big, actually. We maybe don't need it to be quite that wide. In fact, it's going to take a lot longer to 3D print that way. But it'll look cooler. Yeah, I think it'll look cooler that way. Let's make it look cool. So I think we want maybe 100 millimeters in diameter for this base, and we'll be able to change that later. So we'll extrude that up, and we only want the base to be like 3 millimeters thick. And then we'll make a shaft coming up the top. And how thick do we want that? Let's just eyeball this. Maybe 20 millimeters. This will get clearer as we build it up. Actually, I want to change the sketch plane that's on to redefine sketch plane, and we'll use that one. That way when we extrude it up, it's coming from the bottom. And we'll just make this really long for now, and then we'll change it later. Because I'll take my best guess, and my best guess is going to be 100. Oh shit. Not cut, join. There we go. And then we'll want to make a nice billet there. Let's see, and if we want it to look good, we probably want it to, yeah, that looks pretty good. 25. Oh, we'll go 22.5. That looked pretty good, actually. Then we'll give that like a 1 millimeter, 2 millimeter fillet. Kind of like the base of a lamp there. 1.5. All right, now we got to start building our tabs on. So for this, I'm going to start with one central one and go out. And we might need to make like a little square up here. We'll get to that soon. I'm just going to give it a shot the way it is. And I pretty much have to copy this exact hinge profile onto there. So I'll edit that sketch just so we can see what we're dealing with. I started off with a 6.6 millimeter hole, 11 inches up. One second, guys. I got to reply to a text. I'll start off with your hole a few millimeters up. Nice of you to join us, Jason. That's kind of funny you can talk as me while I'm streaming. It looks like I'm talking to myself. Alright, so I actually have to start with a side profile. So I'm going to delete that sketch and start a new sketch with this side profile. Then we're going to project, include that. Love you too, J-Bone. 6.6 millimeters. And we'll make a line going to this midpoint. Make it vertical. And 11 millimeters. And then what was this one? The OD of that. Oh, we had a 6 millimeter gap. And I think we're going to be cutting it close here. We might need to make like a little block for this to fit onto. Well, maybe not. I think I'm just going to come like straight down on this. Yeah, I'm pretty sure I'm going to have to make a block for this to fit onto. Oops. I got to make that tangent. Tangent. Then we'll extrude this symmetrically 3.5 millimeters thick. And then that should work for that. But we're going to have to make a little block on there before we do that. Yeah. Okay, so we're going to roll that feature back. And make a little rectangle up here. And that only needs to be... Yeah, we'll go 22. Or you know what? It only needs to be the... It can be tangent to this shaft. And then I don't even need to dimension it. Let's just give that... maybe 5 millimeters of thickness. And I want to see if I can fillet that to actually look nice. Three. We can go 4. We can go 5. No, we can go 4 though. And can we do that too? We'll get into that later. There we go. I should do that last, actually. So now I need to redo this. The geometry doesn't exist anymore. So we'll project include that. Oh yeah. I'll show you that in a second, Jason. That actually ends up looking good. I made a mask in Photoshop. I'll show you once I just don't want to break my train of thought here. I'll show you once I am done with this part. Yeah, I figured that'd look better than just a straight up border. And I can give you the files you need to do that too, so that you can do it. I'll just show you that. And what did I do here? 11? Yep. And I bring that straight down. Tangent and tangent. All right, it's review warning. One edge missing. How do I get rid of that edge? There we go. So we got to be sure to include those. And then we can make a little pattern. And okay, now I got to do a little math in my head. If it is 3.5, it's 3.5 plus 4.1. And then I gotta do one the other way too. Negative 3.5 minus 4.1. Oops, that didn't work. Oh, minus 4.1. Duh. I think I want to make that rectangle a little bigger than that. So I'm going to remove these tangents. We'll try, I don't know, 24. Make that equal. That way, can throw some fillets on this bad boy. And then some fillets here. Actually, yeah, that looks pretty good. I was thinking about making this flush with that edge, but the extra material off the ear actually does help with the bending of these when they get squished together. So structurally, it's less likely to snap if I have a little more room from this edge to there, from that face to that face. Cool. I think this part's done. That actually turned out pretty darn good, I would say. Just looking to see if there are any finishing touches I want to do. All right, let's save this. We'll call it stand. And we'll bring this into the assembly. And we'll see how bad I messed up. Oh, hell yeah. Look at that. Yes. That is going to work beautifully. Oh, I'm actually pretty psyched about that. Hell yeah. All right. So let's get that all positioned. So the first thing I'm going to do, actually, I need to make that the basis point of this whole thing. So now that that's in there, I need to ground it. And I need to unground this, so now this will move freely. Well, apparently not. Okay. Anyway. Let's add a joint. Cylindrical. Oh, you know what? I need to fix some of these other things first. Unground, unground. Okay. Now I think I can do that. I'm gonna fix this crap later. Alright, let's figure out what's giving us some trouble here. Okay, so we'll replace that. That one should be good. And then add a joint. Yeah. And then the other one there. Okay. So get rid of our phones. Now if I unground that, unground. Okay, now that can move freely. I think we should be good now. Boom. Now I need to do a planar one. And we'll want just a little bit of offset to center it up. And I think it's X direction, 0.3. Nope. Is it Y? Let's see. There we go. All right, now our dude can pivot up and down. The only thing I'm noticing now is that this radius is a little too extreme. I'm going to change that on the hinge. I'm going to make that 2.5, and in fact, I'm going to change the profile on this to use, instead of 15, we'll go half of that. And let's see how that looks. Much better. There we go. That's fixed. That is fixed. That looks pretty good. The only other thing is we do have to use the right length screw now down here, because obviously if this screw is sticking out through there, it's going to run into there. So we got to make sure we're using the right screw there. Jason, are you still watching? Let me know if you are. I'll show you how I did that effect. I could just make this a little longer too. Okay. Well, yeah, it might be worth making this a little more compact. So let's do that on the stand. I'm actually going to get rid of that for now. I need to measure that distance. It is 18.6. Let's just make that exactly match up. Well, okay. That might mess stuff up a little bit. Yeah. Okay, we'll go 19. 20. Yeah, 20 looks pretty good. We just need to reduce this fillet a little bit. No, you know what? I'm going to make that shaft a little... We're going to make that shaft 18. 18.6, actually. Because then that will line up perfectly up here. (18.6) by 18.7. Okay. Oh, okay, Jason. 1 second and I'll show you. Hmm. There we go. $18.6. Now that should line up perfectly. Oh, 18.7. Duh. 18.7. Boom, look at that. Now I need to redo this fillet. How much can we get that? 3, 4, 3.5, 3.6, 3.8, 3.9, 3.85. Maybe add just a little bit of a fillet. Okay, I might want to revisit that. Anyways, I'm supposed to show you how I'm doing this. So, I will show you how I accomplish that. So basically I created this image that is just like a mask. And I just made this in Photoshop, so white shows the image and black makes it transparent. So it fades from white to black around the edges there. And I also have one like this on the webcam, except it's a little more... Oh, okay, first I'll just show you how I do that. So I gotta bring OBS over here. Boom. Okay. So I'll go to my video loop here. And on filters, it is an image mask / blend. And then I just select that image and boom, that's what it does. And I have one on the webcam as well, so that when I stick my hand up, like it fades the edges of my hand too. So for that one, I used one that's like slightly more narrow because you don't want quite as big of a fade for your body going out of the frame as you do like outer space. So I'm using two different masks, one on the webcam and one on like the background there. So that's how I'm doing that. So on this, mainly what I'm thinking of is I need to do this in a way that's 3D printable, which means I can't have any steep overhangs. I mean, I suppose I could just do that. I'm just curious what that looks like. Yeah, I can send you those for sure, dude. Oh, much better. I don't think we need quite as big of a fillet here anymore. Maybe just 1.5? Yeah, that'll work. And then this is too big too, I think. 1.5. That way I think the 3D printer should be able to reach this. I don't know though. Maybe I need to make the shaft smaller. Let's try that once. See what happens. Go 15 maybe? 16? Oh, that actually looks a lot better. Let's see where we can get this now. So I'm also, let's just go crazy with this, huh? Let's put another fillet there. Oops. Oh, that looks great. Yes. Now it has a nice smooth transition. I might be able to reduce that one a little bit. Let's see how, yeah. Well, I wonder if I just suppress that, what happens? Suppress. Hang on, what was this one? It was 5. Suppress that feature. Do a fillet. Yeah. I think that's probably better. I don't know. Let's see, do I like that better? Or that? That one, this one. Probably that one. Or not that one. Yeah, we'll go with this. Let's take a look at this, update that. Much better. I could make clearance for those screws, but I think just using the right length of screw will help. I have shorter ones. In fact, I think I have 1/4 inch ones. So why don't we just grab that one? And let's see how these work instead. So we'll bring that into the project. Alright, so let's get rid of that charging pad. I'm going to delete that screw. And delete that joint. Oh. Hang on, what did we do wrong here? I need to fix something first. What's that one? Okay. That should be good now. Okay. That should be good. Let's bring in this shorter screw. I think I should be able to just do a rigid joint here. No, it doesn't quite do what I want it to do. We'll go cylindrical. Just pick that, and then we'll pick that. And then we'll go planar. Get that back face, and then do that one. Perfect. All right. So now we don't have to worry about screw clearance. Yes. Cool. So now we got to worry about getting these to fit in there. And in order to do that, I will first do a planar joint. There and there. And that's right there. And then this bolt has to go in. And it looks like I picked just about the right length. So that's good. Now we just need to worry about sinking this bolt in. All right, I'm gonna take a water break here for a second, so I will be right back. It's starting to get late, so I might end the stream soon, but I am gonna finish this piece up and I will get it on the 3D printer tonight. And you guys can see me do that because I have a camera on my 3D printer, actually. I think I'll get the stand and the hinge printing tonight because we still might make changes to this. There's still a few things left to do before I consider it perfect, so to speak. But the stand, it's pretty clear cut what we got to do with that. So. Cool, I'll be right back. Alright, I'm back. So, the next step is going to be making the feature that holds this bolt in place from turning. So this is a carriage bolt that has a square profile, and that way when it sinks into something, it doesn't rotate, and that way you can tighten this nut on. So, let's do that now, huh? I think I want to leave this amount of thickness here, so we'll just build more onto there. And what I'm looking at now is we might need to get a longer carriage bolt. Actually, that's probably going to be good, I think. There's enough threads for that to go on to. Typically, only the first 3 threads do all the work holding something in. So, I think that should work fine if I do it that way. So let's give that a shot. We'll open up the stand again. And what side was that on? I'm just going to color one side a different color just so I know what it is in the assembly and don't have to redo stuff later. Oh, that didn't work. We'll just make that red. No, I don't want transparent. There we go. Now that side is green and this side's regular. I can't tell you how many times I've made a symmetrical part and then figured out that I put a feature on the wrong side. So the green side is what we got to add on to. Okay. So we got to build more material on here. And let's check to see that bolt head size is 7.8 millimeters. We'll just make that we'll just make that 8 so that it's just flush against there. And the diameter is 16. And then we got to figure out how far back to put it. And I kind of like the amount of clearance we have right here. So let's just measure that. 5.3. We could probably get away with a little less than that. We'll go with 5. Right? That'll work. Yeah, we can go get 5 millimeters. And now we got to cut a square profile, and that distance is 6.48 millimeters. So we typically with a carriage bolt you want to give it a generous amount of clearance. So 6.5, we'll give it maybe 2 millimeters of clearance, 1.5. Well, I could just go 1 and I think it'll be good. So, new sketch, we'll make a center rectangle. And 6.5 plus, we'll go 1.5. Equal. And then we got to figure out how, oh yeah, we just want to go up to that surface. Okay, so we'll extrude that up to this surface. Boom. So now we have our carriage bolt slot. And you see how there's a radius there? We're going to make the part a little stronger by adding a fillet on this inside right here. And it doesn't have to be a lot, maybe 1. Actually less than that even. 0.5. And then we also want to give it a little bit of a fillet here in case the bolt has one, because it's impossible for the bolt to have a completely perfect corner there. So we could go 0.5 there. I think I'm actually going to go 0.75 maybe. That way it fits in easily. And that should work pretty well. And because I like fillets... Oh, crap. You know what I just realized? This is not going to be 3D printer friendly because we got this drop off right here. And I think I'm just going to manually compensate for that, honestly. Alright, so let's cancel these fillets for now. That one's fine. So we got to make this 3D printable, and I know exactly how to do that. So instead of just using a circle there, we're going to use a rectangle and make the bottom flat. So now we have that. And at this point, I'm going to lessen that fillet a little bit, make that 0.5, which should be fine. Because then we're going to have 3.5. Alright, the first thing we're going to do to make this 3D printable, and again, I'll go over the reason this isn't 3D printable. You can't have less than a 45-degree overhang when you're 3D printing a part vertically, or else the print will fail. So in order to do that, this is just a flat overhang. We need to make like a 45-degree angle coming down from there. And in order to do that, I'm going to take some material away. Now, if we were manufacturing this out of metal or some other material, then this wouldn't even apply. But this is I'm doing this specifically because we're 3D printing this. So then we can just cut that. We'll just go through all. And then we'll make another sketch again. And continue that line to there. Got to project that. And boom. So then we'll extrude that to object. There. Now it's 3D printable. And we'll add a nice fillet onto there. Cool. I think I won't put a fillet there. That way the bolt head can fully rest on there. And oh, I'm so dumb. Because support material has to be built up from there to there now. Well, actually, I think that's fine. The only place, if I add supports into this model, the only place they'll be is through these holes, which holes, as far as support material is concerned, are usually fine. You can usually 3D print holes without support material, even though up here it gets to be, you know, it gets to be where it would use support material there because the angle is less than 45 or greater than 45, but usually printing holes goes fine. But at least me building it this way makes it so that we only need a little bit of support material. I'll just have to either drill that out or chip it out. Okay, let's see how that fits up. Okay, it's looking like I might need a little bit of a tighter tolerance there. .48. All right, so 6.5. What was it before? Plus 1.5? Obviously, that's too much. We'll give it 0.8. And for that fillet, we'll take that down to 0.3. That is looking pretty good to me. There we go. That allows for a lot less play. Cool. That should work. Now I'll just assemble that from there to there with the planer. Look at that. And I probably don't need to make this quite as big of a diameter as I have it. Looking at this again now. $1.5. Yeah, there we go. We'll go 1. That looks pretty good. And I think that's actually the right length for that bolt, too. Cool. Alright, so I'm gonna get this part on the 3D printer, and I think we should be good. J-Bone, don't even get me started. Don't even get me started on how good Ben looks. I wish he was watching. Alright, so I think tonight I'm going to print out this part and this part. And then I'll order the hardware. And then we just got a little more work to do on this guy before I'm ready to call it good. Because we need to make room for the USB port. Because there's a cord that comes out of it. Yeah, Dragon Samurai, I have a 3D printer. And I'm actually just about to start a 3D print if you want to see how that works. So, why don't we start that process? I have a Creality CR10 3D printer. Let me show you what that looks like real quick. Yeah. So, Creality CR10S. Yeah, this one has honestly worked really well for me, and it's pretty affordable. You can see the prices here, $434, $354. I think I got mine for like $500, but the price has gone down since then. And it works pretty well. Yeah, this is the exact printer that I have. Hang on. Flip a bigger picture of this. It's a little blurry, but you get the picture. Yeah, this printer works really well. Honestly, it'd be a good starter 3D printer. If you had a little more money, I would get a Prusa if I were you. So if I was gonna buy one now, I would actually get a Prusa MK3. It doesn't have as large of a build platform. Okay, yeah, you have 600 pounds? Or is that, yeah. I think that's enough. But I would get this one because it's a little more all-in-one. If you are mechanically inclined, you could definitely go with the CR10S because I have not had a single issue with mine. A lot of people who do have issues with it, it comes down to user error. They're just doing things a little wrong. But yeah, I would definitely recommend a CR10. Actually, I think Creality has better printers now, probably newer versions. Let's see what they got. $773. Okay. Yeah, if I were you, I would go with the Creality 3D printer then. Oh man, this is on sale right now. You want the CR10S. Don't get the regular CR10. The CR10S has an extra motor for the vertical axis, whereas this one just has one motor, so it can kind of mismatch a little bit. I would honestly recommend getting the CR10S, or you could probably afford the CR10S Pro, which I'm sure is actually better. But yeah, I would recommend either one of these. Honestly, you would not have an issue if you got the CR10S, because there's so much history out there of people using it for, I think it's been out for like 3 or 4 years. No, probably like 2 or 3 years. But there's a variety of upgrades that you can 3D print to. You can 3D print new parts for your 3D printer on the same 3D printer. It's pretty cool. But there are a bunch of upgrades for this one. So you're not going to go wrong with this one if you get it. So that would be my recommendation. That's the exact one that I use. And if you got a little more money, this one's probably better because it's the Pro version. I don't have it. I haven't used it. But it's probably a little nicer. Yeah, it's probably a little nicer. But then again, it kind of makes me think that they're just using fancier electronics with the same core components. I don't know how much of an upgrade it actually is, but it looks a lot sleeker. If you got the money to blow, you get that one. But this one's on sale, so you might want to get that one too. But I'm going to get a 3D print started, so if you want to stick around, I'll show you how this one works. So I just designed this guy. Tonight we're going to print off this part. Yeah, we'll just do the stand. And I'll print that one separately because that one doesn't require support material. Hey, thank you for the follow, Dragon Samurai. Much appreciated. But yeah, let me show you how this all works. So I'm going to turn on my 3D printer. I actually have it set up remotely. I'll show you how that works too. I'm using something called Octoprint. It uses a Raspberry Pi, like mini computer plugged into the 3D printer. It's an upgrade. So this doesn't come with your 3D printer, but if you want to set it up this way to where you can remotely start prints from your PC, it's actually really easy to do, and there's a lot of tutorials. Yeah, the CR10S has a lot of history behind it. So if something goes wrong, it's actually pretty easy to find out what the issue is, which is another reason to get it. But yeah, I'll connect to this 3D printer. Error connecting to printer. Oh, it's still booting up, it looks like. Let's try again. There we go. So I've got my webcam here. And yeah, it's pretty cool because if you set it up with a Raspberry Pi, you can set up a webcam, and there are apps that you can use to remotely monitor your 3D prints. 1 second here. So that is my CR10S, and we're going to prepare a part to be 3D printed. So we're going to do the stand tonight. And I'm going to load up Cura, which is a slicer. So 3D prints take a long time to print. So usually it's something you start like before you bed, and then before you go to bed, and then you wake up and it's done. The really small prints can take maybe 45 minutes to an hour, but if you're printing something big, it can take 15 hours. If you're printing something really big, it can take several days. So it's a very slow process. You have to have patience, but it is well worth it, honestly. But you just got to kind of plan ahead, you know. Cool. All right. So the first thing I'm going to do. So this is the part we're going to print. So I'm going to save this out as an STL, which is the format that a slicer uses to get this part ready to be manufactured. So we'll go stand V7. V7 because that's what it is up here. Every time you save, Fusion 360 adds a new version number. So we'll do that. And we'll bring this into Cura. So I just need to find that. Bear with me here. Yes. A slicer actually shows the time it takes to 3D print something. I'll show you that in a second. That way you can kind of plan ahead. And you can scale things up or down. If you're not making a mechanical part, if you're making a part that's just like artistic, you can make it really small and then it won't take a long time. Obviously, if you want it to be bigger, then it'll take a lot longer. So here we go. Got the stand. And I need to rotate it correctly. So I'll just grab that. Rotate it 90 degrees. And there we go. So now I am going to get ready to slice this thing. And there are a few settings I gotta tweak. So as you probably already know, 3D printers build everything up layer by layer by squirting plastic out of a little nozzle. So there's all these lines, and this is what it'll actually look like when it 3D prints. So I'm going to change some settings here. This looks, on the right here, this probably looks confusing to you, but as you get into it and do more research on it, it's actually not that hard to use. I'm probably changing a few settings you can't see, so I'm going to resize my window here. There we go. Yeah, not always, actually. You need supports for where there's overhang. So a 3D printer can only print by building up something that's under it, right? So it needs supports, for example, this is tall, but there's no supports that it needs to do right here. The only place it actually needs supports are in these holes right here. Because a 3D printer can print an angle of about 45 degrees, but anything steeper than that is too much of an overhang, and then it needs to build up a bunch of material underneath to actually support that material when it gets to that layer. So right here, yeah, that's the only spot that it needs supports, and I was conscious of how I designed that. Like for example, you see this 45-degree angle right here. If I didn't make that angle and if I just made it like go straight across right there, it would have had to build up support material all the way from the bottom up to there. So in order to avoid that, I actually built a little 45-degree angle into the part right there. And so I'll turn supports off just to show you what it's doing. If I turn off support, it'll reslice everything. And it takes just a second sometimes. Got a lot of calculating it needs to do. So no supports, it looks like that. So the reason this 3D print would fail if I printed it out this way is because right up here, there's nothing underneath that. So when the 3D printer gets to that area, it would squirt out plastic and all that plastic would just fall down right here. And like that area of the part would just be ruined basically. Actually, you know what? I don't know if I care about that. Yeah, okay. So you get it. One thing that not everyone knows is that if you're just printing holes, holes usually tend to work fine. There's enough of a gradual increase layer by layer to where the print's not gonna fail. Like this will be able to get across right here because it's a gradual increase. So holes will work fine, but the area of the print that would fail for this specifically would be right there. And it's preferable to design a part without the need to use supports. So in order to do that, I'm actually going to go make a modification to this. I just realized I can make this in a way that I don't need to use supports. So all I'm going to do is take this chunk out of the top right there. And I might make this just straight across instead of a... Yeah, okay. Alright. I know what I'm going to do. So we'll make that collinear. And we'll just take that... We'll just kind of arbitrarily make that 5 millimeters. And then we're going to redo that extrusion. Be like that. Cool. Just going to hold off on that. And let's see. We're going to go back a little ways. So it depends on the nozzle you use. Question was, do all 3D printers have lines, or is there a way of making the print smooth? So, yes, you can use a smaller nozzle, and then that will reduce the layer lines. That'll make it a little more smooth. You can't completely get rid of the laser line. You can't completely get rid of the layer lines. There are certain 3D printers that pretty much have no layer lines, but they use resin and a laser. They're called SLA 3D printers, but they tend to be a lot more expensive, and also the parts aren't as strong. So they're useful for very finely detailed parts, smaller parts, but it's not going to have as much strength. So there are ways to smooth out the lines after you're done 3D printing something. And you can do that by sanding the 3D print, and you can fill it with putty. I think Bondo is a type of putty that a lot of people like put on their 3D prints to smooth it out. And then you can like spray primer on it and paint over it. It is a decent amount of work. Personally, I don't think the layer lines look that bad when you're 3D printing something, so I've never really had to do that. But yeah, that's kind of the gist of it, I guess. So we'll make that collinear, and then we'll cut this out right here. And now we just have a U-channel to support that bolt. And I have to redo some fillets here. Okay, that's fine. And now that's more of a U-channel now. Then we'll build that up again. And it looks like we got to make that slightly less for up there. I might just not include those edges, actually. Not those up there, anyway. I think I made that a little too tall. So we're going to take that down to 4 millimeters. Yeah, that's better. Okay. And then with that, we'll go with like 0.5. And then... looks a little weird with that overhang there, but I think... I'm going to try a different method here. Yeah, there you go. Creality CR10S Pro. I don't think you'll regret it. And if it gives you issues, there's a lot of history on that. Well, I think there's a lot of people who have that printer. So you should be good with that one. And I hope it works well for you. But yeah, no problem. I'm glad I could help. Oops. Going kind of crazy with my fillets here, but I think that ought to do it. And then I don't think we'll have to print with support now. So apart from spare filament, I'm trying to think what I did when I first set up my printer. Honestly, it comes with most of the tools you need already. I'm just looking over at my 3D printer, kind of thinking what I need. Honestly, it'll come with a little bit of filament, but it's only a tiny roll, so you want to get more filament, obviously. And then there are probably like some upgrades you can print for your printer out there. But I would just get spare filament and start there and just look up some YouTube tutorials on how to get started with that specific 3D printer. And I think you should be good to go, honestly. But I would just search around, search for that model name, like what do I need to get started. There'll probably be people out there who have asked that same question online, and they can probably, you might be able to find some answers there. Oh, so that's a 30.3. All right, well, I think we're good here. I think this part is ready to be printed. I want to give that a little more surface area. I think I want to just get rid of that. Or make it a lot less. Oh, whatever. Ah, it should be fine. All right, it starts to fail after that. Let's just leave that. It'll be good. Do one more final check here. Cool. Well, that looks really good. And now we can 3D print this thing without any support at all. And it should work. Cool, so I'm gonna resave that out. Yep, you should get PLA filament in 1.75 diameter. That's the most common PLA. If you search 3D printer PLA on Amazon, that'll work just fine. I'll show you specifically the filament that I use. I would recommend Hatchbox PLA 1.75. I usually just go with black, but if you have a specific color you want, you can do that. This is what I recommend you get. So this should work pretty well for you. It's never really given me any problems. I usually print at 200 degrees for the nozzle and 50 degrees for the bed temperature. But yeah, I'd recommend picking up a roll of this for filament. It's always worked well for me. And you should be able to get it in the UK or Europe or wherever you're at too. As far as I know. Oh, I should have called that stand V8. We can rename that. Oops. All right. So we're going to start over on this. I'm actually going to load up a different project that had all my good settings. So the first 3D print that a lot of people do is called a benchy. It's a little boat. And you can print it without supports. And it's kind of like a printing test. So if I were you, Thingiverse is also going to be your friend. They have all sorts of 3D printed stuff you can download. So number of makes. Yep. So this is what you'll probably want to do as like one of your first prints. So this is just the basically the benchmark 3D print. And if this turns out good quality, then your 3D printer is up and running if it looks like this. So recommend printing that out when you get it all set up. So I'm going to get rid of that one. I'm going to bring in the new version of the stand. Yeah, Thingiverse. Let me show you again. Thingiverse.com. I'll throw a link in the chat for that. There you go. And then I'll throw you a link for that benchy as well. There you are, no problem. Glad to help someone who is new to 3D printing. So I'm going to turn. This should have all the right settings for what I need. So don't use my settings as reference because I have modified my 3D printer and it's also different than yours. So if you're looking at anything here, Just look for the recommended settings for your 3D printer specifically. I guarantee you they will be out there if you just search for them. There are also Facebook groups surrounding your specific kind of printer as well. So, cool. Oh, good. Glad you made it. Glad to hear that. Oh, it's funny you tell me on my stream. Glad you're tuning in. We are getting ready to 3D print this thing that I designed. And this is what we ended up with compared to last time. We had to make some modifications to it. But it should work a lot better now. I made this little hinge thing. And you tighten it down. So we're going to print out the stand for that tonight. And because I'm not using support, I think we can also print this out too. So I'm going to get 2 parts on this same 3D print. So we'll save this as STL. And this is called Hinge Rear. Hinge. Oh, hang on. I should go to the actual part when I'm saving this out. Save as STL. We'll do that. Hinge rear v4. So we got that saved out. And then we'll bring that in as well. So we need to rotate that 90 degrees. And might need to move these. Having a little bit of a tough time processing this. There we go. Oh, that might be why. There we go, much better. Alright, so let's get a top view. I think I'm going to leave that in the center. Center selected model. And then I'll just move this a little bit. That way. And then it'll slice it. It says unable to slice, but it should be able to. There it goes. It's a little finicky sometimes. And then I just got to check my settings here to make sure everything's right. Layer height 0.2. Blah, blah, blah. Wall line count 2. Yeah, there's actually a lot of things you can do. 3D printing is kind of an art form in and of itself. So just to make this a little more strong, I'm going to increase the wall line count to 4. But yeah, the world of 3D printing is a fun world, so I definitely recommend getting into it, Dragon Samurai. Top layers. We don't need that many. Not gonna hurt anything. Okay, so before I actually print a model, I like to step through every layer just to see if I see any problems. So using Cura, there's a little slider on the right here where you can step through the entire layer of your print. So I'll start off right here, and That all looks good to me. And now it's just kind of building up and up and up and up. So now here's where we got to focus and just make sure that all looks good. Looking good to me. Okay. Okay. And I think this should be fine. There come the holes. And there's where they join. I think that should be fine. I know the rule is if it's more than a 45-degree overhang, you shouldn't print without support. But for holes, you can usually get away with it just fine. Cool. So this is ready. And I am going to, first of all, save this project. So, sorry, I'm just doing that on my other screen here. Phone, charging stand. Stand V8. And hinge. I usually put the date. 5. Having some technical difficulties here. There it goes. All right. So now save to file is what actually saves the G code. And G code is the file that you actually send to your 3D printer. And if you, when you get your 3D printer, you'll actually have to put it on an SD card, this file that I'm saving. All right, so now we're ready to 3D print. And I'll go over to where I control my 3D printer here. And we'll upload the file. Phone charging stand. There we go. And it shut off because I have a timer on it to shut it off for inactivity. I'll just have to reconnect. I might have to reload this. Okay, there we go. It's connected. And then I'll load this G code here. Now, one thing I am going to do before I start the 3D print is make sure that the bed is level. So I don't know if they have automatic bed leveling on the Pro. They might already. So you might not have to worry about this step, but it's something that I need to make sure is okay. So I'm going to be fumbling around with that, and I'll just put it on this side of the screen over here. You'll actually be able to see me messing with it. So what I'm going to be doing is checking the nozzle height to make sure that the height is at the right setting. Auto home. Good. That I need to adjust a little bit. Okay, so that all looked good. Yeah, yeah, if that's auto level, then you're actually not gonna have to do the step that I just did. So I have to manually level the bed by checking the height of the nozzle above the bed in each corner. Now, if it has auto leveling, that's probably good you're getting the Pro, because if that has auto leveling, you don't have to worry about it because the machine checks the height itself for you and adjusts itself. So you're not gonna have to worry about that part. But one thing that you do need to do before you do a 3D print is clean the bed off. So I'm going to do that now. I recommend using 70% isopropyl alcohol just to make the bed surface clean before you 3D print. So right now I'm controlling the nozzle. I'll move the bed forward. I'm using these arrows. And then I'm just going to wipe it down real quick before I start the print. And while I'm doing that, I think I'll preheat the bed because that usually takes a little while to warm up. And I know I'm going to set it to 50 degrees Celsius or centigrade, as you guys say. Do that. That's warming up. I'll go wipe that down. Cool. So now we should be ready to print. And I am going to get that started here. So I'm going to just turn that off so it's cleared. And then I'll just hit print. And oh, actually, I'm going to cancel that because I set the bed temperature too high. It's at 60 when it should be at 50. So that's one thing I forgot to check because I just assumed that I had it set right. So printing temperature 210, 200, and build plate temperature is 50. Print speed 80 is pretty fast, but it usually works fine for me. And I'm going to leave it that way. Traction distance 2, that's good. Travel speed. I'm going to bump that up to 220. Okay. So now we should be good. I'm going to overwrite that G code. And I have to wait for this to... Kind of annoying when you cancel a print. It waits for the last G code command to finish, so the bed's got to heat up to 60 before it cancels. It's harmless, but it's just annoying to have to wait. See, it's in the process of canceling right now. So, just annoying. Well, we'll get there. We will get there. We're almost there, guys. Oh, there might be a little blemish right there. Well, I'm not too worried about it. All right. So, let's get rid of that, then upload the new one. We'll load that and hit print on that. And now we should actually be off and running. There, that way you guys can see it. So it's heating up right now. And you can see the target is 200 degrees. And the tool is starting to heat up, which is going nice and quickly. The tool doesn't take too long to heat up. Usually it's the bed that takes a long time to heat up because it has to heat this entire surface. Whereas the tool, it just has to heat this little nozzle right here. So the bed always takes a lot longer to heat up than the tool. It can take like 5 minutes. If I know I'm about to start a print, I usually come in here and oop. Okay, 50. Good. Triple check my settings here. Yeah, we're at 50 and 200. Okay. So once it actually starts printing, I'll hop over there. And I usually make on-the-fly adjustments when it starts printing with the leveling the bed. Just to make sure that the nozzle is at the right height. Sometimes just by looking at it, you can tell once you get an eye for 3D printing. So it's starting now, so I'm going to go over there and just make sure the first layer goes down okay. You'll be able to see what I'm doing. So... So far, so good. All right, so the first layer is actually going down really nicely, and I'm really happy with how it's printing. So I think this is going to be a successful print. One thing really cool, the way I have it set up, is that I can view the layer as it's going down. It might have to load here. Let's see if I can show you layer by layer. Oh yeah, it's analyzing. You can actually see a live view of what the 3D printer is doing. So, actually really cool. I'll show you. So I'll zoom in. So it's filling that out right now. And what that actually is, it's on the first layer right now. So it's this part, it's actually filling in that right there. And yeah, it's kind of cool that you can see in real time what your 3D printer is doing. And if you set it up the right way, you can actually remotely monitor your 3D print too, which I think is pretty cool. So yeah, it's going to finish that. And then it'll go back and fill in this part and then this part. There it goes, finish that. Now it's going to finish that, and then it'll start on this circle over here. There it goes. I'm just going to make sure that layer is going down okay. All right, that is working absolutely beautifully. So it is just laying down this outer ring right here, right now. And then once it gets these 1, 2, 3, 4, 5 lines, it'll move to the middle. So it's on the 4th one, on the 5th one. So after this, it's just going to start laying down the middle material. There it goes. That's going pretty fast, actually. Cool. Double check that. All right. Well, guys, I'm really happy with how this is turning out. The 3D print seems to be going well, and I'm glad you could watch me here for the whole design process. Before I sign off, I'm just going to recap all the progress that we made today. So, we upgraded the design. Instead of using that big, bulky, one-piece hinge, we made a separate piece that attaches to the back of here using screws. And we made this whole stand, and it uses a bolt and a thumb screw, a thumb nut, to tighten down. And for this design, this was inspired by the GoPro mounting system. Yeah, it was inspired by this design, how GoPro mounts their stuff, except I just kind of had my own twist on that. And I designed this part so that it could be 3D printable without supports. So right now, this part and that part are printing off. And I'm going to be ordering this bolt and this thumb screw. And I think I already have some of these screws. So I just need those two parts and we should be good. On the next stream, I will work on this even more. I'll give you a little recap here. There's this charging pad is what fits in there. And your phone can fit on there either sideways or vertically, which is the reason that we have two sets of hooks on here. So I need to make there's a little USB port on the side here where a cable connects. So I just need to make it so that the USB cable has a place to come out. Oh, you know what? I think the stand is too tall. But you know what? I'm going to let it print anyways, because then I'll have a tall variation. It's not a mistake, it's a feature, right? We'll have a tall version and a short version. Okay. Oh, that's kind of funny. I realize that now after I started the 3D print. So before I go to bed, let's make the short version. I'll print that off sometime later. I don't need to do that on stream, but it's going to be really easy for me to tweak this and make it shorter. So the first thing I'm going to do is duplicate this. Stand tall. Cool. So now we have a copy of that. And then I'll go into the regular stand thing here and I'll make it a little shorter. And all I gotta do is change one number. So we'll go from 100 to like, let's see what 60 looks like, huh? That's probably gonna be too short. But let's check how it looks in the assembly. The main thing is that the feet can't, oh, that actually looks pretty good. That'll make it more sturdy too. We can even go a little lower, I think. Just a little lower, I think. So yeah, when I release the design, there'll be a tall version of the stand and a short version. Cool. 50. I might have to settle on 55. I think that might be, well, actually. Yeah, we'll keep it on 55, I think. That way it's a little more low profile. Being a little slow to load it. There we go. That looks pretty good, I'd say. There's enough clearance. Cool. Awesome, I'm happy with that. And then we'll rename this to Stand Short. stand short. Boom. What days do I stream? For me, it is extremely random. I don't have a set schedule. So you should check out our channel, our Twitch channel, because it's not just me who streams. So we go by Arms for Elephant, and we are actually a heavy metal band. And each of us can use a stream. The bassist, Jason, streams pretty often. He likes to stream Apex Legends a lot, WoW, and various other games, Call of Duty, things like that. He's really fun. I play guitar in the band, and I don't stream as often, but when I do stream games, it's virtual reality games because I am a virtual reality developer. And I'm also have a mechanical engineering background, which is why I do these kind of streams as well. So my job is creative technologist, and I work with virtual reality technology and interactive technology and interactive installations and things like that. So I make kind of hardware and software and try and mix them together in all sorts of interesting ways. This phone stand is just something I've been wanting to do for a while because this is literally something I want to have on my nightstand and to have at work. And I'm just going to release this design to everyone. Actually, when this is done, you should keep tabs on this, and then it'd be cool if you 3D printed one because you were here when I was designing it. That'd actually be really cool. So this would be a cool thing for you to print, actually. And I'm going to provide all the parts and everything, a parts list and like the model number of this charging pad you can buy so that you'll have the whole parts list to buy all this stuff. But it's going to be random when I stream. I'll probably be on again maybe tomorrow, sometime this week. Either way, I'm going to upload this footage. You'll be able to see the videos. I'll link you to my YouTube channel is where I'm actually going to post. I'm actually going to upload these videos specifically. So 1 second here. Grab my channel for you. There you go. That is my personal YouTube channel. So, personal channel, Matt Foreman. And then I'll also link you to our band's channel. So there is the band channel. And I think this is probably a good place to stop the stream. I'm just going to check on that 3D print one more time before I completely sign off. All right. Well, things are looking good, and I'm glad that you're able to join us here today, Dragon Samurai, because this is probably a good this is actually a really good stream for you to catch if you're trying to buy a 3D printer. I'm glad I could help you out. So, with that being said, I think here's where I am going to end the stream. So, thank you all for stopping by. I really appreciate it. I love doing these kind of streams where I actually design something on stream and build it and 3D print everything. I hope to do more of these. I actually do have some ideas for some more inventions I want to create. So we'll see if we can get to that. Either way, it was nice to meet you too, Dragon Samurai. Thanks for stopping by. Thank you to everyone who came by tonight and said hi. And yeah. Have a good night. Have a good day wherever you live. So take care, guys. Bye-bye.